minus 175 minus 3 would give me 2 degrees at the top. Again, it would be most beneficial to try to find the side that they share. So I'm going to call that side Y. All right, using our law of sines, we could set up a ratio comparing the things that are opposite. So 2 degrees would go with 700 feet. 3 degrees would go with my missing side. So the sine of 2 over 700 feet equal to the sine of 3 over y. When we cross multiply, 700 times the sine of 3, y times the sine of 2, and then we're going to end up dividing both sides by the sine of 2 to isolate y. And I get that that side is 1,049.7 feet so far. All right, then we can take that, just like how we did in the problem before, and look now at the right triangle that we have. This angle is 5 degrees. We know that this side is now 1,049.7, and we're looking for how tall the lighthouse is. So this would be opposite over hypotenuse again, so sine. We would multiply those values, so 1,049.7 times the sine of 5. And the lighthouse should be 91.5, if we're rounding to the nearest tenth, feet tall. All right, question 5. Juan and Romello are standing on shore 10 miles apart. Both can see the same ship in the water. The angle between the coastline and Juan's line of sight is 35 degrees. The angle between the coastline and Romello's line of sight is 45 degrees. How far is the ship from Juan? All right, so let's think about this. These two people, let's say we've got Juan and Romello, are like standing on the beach. And then somewhere way out here in the midst of the ocean, they can see a boat. All right. Between Juan and the boat, his angle is 35 degrees. Remember, it always has to come from a horizontal line. In this case, the coast represents that. Romello, looking towards the boat, has an angle of 45 degrees. And we are looking for how far the ship is from Juan, which in our case would be this distance. All right, first, find our missing angle so that we have enough to make a pair. I'm sorry, and this is 10 miles. So 180 minus 35 minus 45 would give me 100 degrees at the ship. All right. Secondly, we have enough to make a pair because we could compare 10 and 100 degrees and 45 degrees and x. So that's going to be law of sines. So sine of 100 over 10 miles is the same as the sine of 45 over x. Cross multiply. And in this case, divide by the sine of 100. .18 or 7.2. In this case, we're measuring in miles. All right, and for our last one, Ted, Barney, and Marshall are camping. Their 3 tents are set up around a campfire in the middle, so we are going to have a triangular picture here. The distance between Ted and Barney is 15 feet. The distance between Ted and Marshall is 20 feet. And the distance between Barney and Marshall is 17 feet. What angle does Marshall's tent create with Barney and Ted's tents? So first let's sketch a picture. We are going to have a triangle. We've got Ted, Barney, and Marshall. The distance between Ted and Barney is 15 feet. Between Ted and Marshall is 20 feet. And between Barney and Marshall is 17 feet. And the angle that we're looking for is between Marshall's tent and the other two. So this is our missing angle. All right. Anytime we have only sets of sides, so in this case we have a side set up, you have to do law of cosines. But remember we talked about yesterday, if you have a side scenario and you have to find a missing angle, you have to find the largest angle first. And in this case, the largest angle comes across from 20 because 20 is the longest side. And this angle is not actually the angle that they want for our final answer. So this will be like a 2-step problem, okay? So first, since we have to find the largest angle, we're going to have to find angle B. If we want to find angle B, you remember your law of cosines formula from yesterday, if angle B is on the end, then that means B squared is also on the end. And A squared and C squared will be in the middle. All right, so little b would be 20. A and C are 15 and 17. The order here is not particularly important. And then cosine of angle B. Remember when we did these yesterday, if the angle is the thing that's missing, you cannot type this entire string into your calculator. You have to kind of separate it into parts. So I would do 20 squared first, which is 400. You could go ahead and do 15 squared plus 17 squared, which is 17 squared. 514. And then separately we could do -2 times 15 times 17. And this is -510 cosine B. Remember, we also talked about yesterday that these two values cannot be added together because the 510 has something multiplied to it. Think of it almost as like an X. You can't subtract 514 and 510 if 510 has a variable or something that's missing. So we would move 514 to this side, giving us -114 and -510 times the cosine of B. If we divide both sides by -510, then we get that the cosine of B is equal to 0.224. We want to leave this to at least 3 decimal places, remember, so that our angle will be more accurate. Since the angle is the thing that we're missing in our calculator, we have to do second cosine of that decimal. And we get that our angle B is 77 degrees if we're rounding to the nearest whole number. All right, now that we know that, we can add that into our picture. Now, kind of for step 2, we have enough information to set up a proportion and do law of sines because I can compare 20 and 77 and then 15 and question mark if we think about our ratios with our opposite sides. So these two and these two. So using law of sines, I would say the sine of 77 over 20 feet is the same as the sine of angle M, which we don't know, over 15. So similarly, when we cross multiply, 20 times the sine of M, 15 times the sine of 77, and in this case, we're going to have to divide by 20. And we get that the sine of angle M is 0.731. So again, if the angle is the thing that's missing, second sine of that decimal, and angle M comes out to be 47 degrees, rounding to the nearest whole number. Okay. So I'm leaving you the practice sheet with a few problems like this. You'll notice that it says at the top that all of them that you complete correctly with all of your work shown will earn you extra credit on your test on Friday. So feel free to work together as long as we're actually working, and look back through these to kind of help model how you should do the ones on your practice sheet. And then if there are any burning questions, feel free to email me or send a remind, or we can always work through whatever questions we have tomorrow while we're going over your review day. All right.